All right, so welcome to the Gate Academy English channel, my dear. A warm welcome to all of you on the Gate Academy English channel. So, my dear, my name is Umashankar Tripathi, and today in this session, we are going to do previous year questions. We are going to do previous year questions of theory of machine asked from the IIT Kharagpur. As we are know, as as we are knowing this fact that this year GATE 2022 is going to be conducted by the IIT Kharagpur. So it is very important for us to take care what kind of a questions they are asking from all the subjects. So previously we have done a session on previous year questions of fluid mechanics asked from IIT Kharagpur. Now today we are targeting to do some of the questions from the subject theory of machine. Okay. So do not forget, first of all, I request all of you students to first subscribe the channel, like it, share it with your friends so that everyone can be benefited. Okay. Okay. So let's start without wasting any time because the time is running very fast and we have only 5 months somewhat left for the GATE examination. Okay. So we are beginning with some questions. So let's start solving with this one. Okay. This is a question asked from IIT Kharagpur. Okay, so can we try it, my dear? Can we try it? And you can answer me in the chat box. Okay, in YouTube live chat section, you can tell me. In the YouTube live section, you can tell me what is the solution to this question, and please feel free to ask the doubt at any point of time. Okay, so this is the question of GATE 2014. Set 2 and 2 marks. So we know that the IIT Kharagpur have conducted the GATE examination in 1988, 1994, 2000, 2006, and then 2014, and after then 2022. That means this coming GATE examination is going to be conducted from IIT Kharagpur. So we have to solve the questions from all the GATE previous year papers, but obviously, if we give some attention, hello Ajinkya, if we give some attention to this what IIT Kharagpur questions, we'll get some idea that what is the pattern of the question they are asking. Though it doesn't mean that we do not have to solve the complete previous year question. Okay, so can we have the answer to this question, my dear? Can we try to solve this question, my dear? Very simple question. A rigid link PQ of length 2 meter rotates about the pin end Q with a constant angular acceleration of 12 radian per second square. So what I suggest, and always in the classes also I suggest you guys to always try to make a diagram. Okay. So let me try to draw a diagram of it. So we have a rigid link PQ. Okay. So let's say we have a rigid link PQ of length 2 meter and rotates about the pin end Q. So this is the pin end and this is P with constant angular acceleration of 12 radian per second. So let's assume the direction of the angular acceleration is in this direction. When the angular velocity of the link is 4 radian per second, okay, so let's suppose the direction omega is also in the same direction, the magnitude of the resultant acceleration at the end P. So they will see the answer to it. So now we know when we have this alpha, we have a tangential component of acceleration. We have a tangential component of acceleration. So let's suppose this is your tangential component AT. Okay. This is your tangential component AT, and we have one radial component that is AR. That is AR, and both of it are perpendicular to each other. Both of it are perpendicular to each other. Okay, so what is this AT? AT is, we know that, sir, it is R into alpha, and AR we know that is R into omega square. I hope you guys are aware of these formulas and the direction of these accelerations. Okay, so now putting the value, so AT is R alpha, so R is given to be 2 meter. So 2 into 12, so we are getting 24 meter per second square from here. And R omega square, that is 2, and this is 16. for a square, that is 32 meter per second square. Now, if we take the resultant, so we know acceleration is a vector, and when two vectors are perpendicular to each other, obviously we can find the resultant of it by this process, right, my dear? By this process. So, what is this 80? 80 we have as 24 square. AR we have as 32 square. So, we are going to get 24 square plus 32 square. So, root of 1600, that is 40 meter per second square. So the answer to this question is 40 meter per second square. And this is the numerical ability type question. So if you know, from GATE 2014 only, the numerical ability type questions were introduced in the GATE examination. Now, can we have the answer to this question, please? This is the next question. This is the second question asked from the IIT Kharagpur. Can we try it? So this is a question of 2006, 1 marks, MCQ. I think very easily we can answer this question, a theoretical simple 1 mark question. So you would say, yes sir, we know that the number of inversion for a slider crank mechanism is 4, right my dear? We can have the inversion by fixing the cylinder, we'll get the engine or the compressor, so we can fix the piston to get the hand pump, we can fix the crank to get the Whitworth quick return mechanism or genome engine, and we can fix the connecting rod to again get the crank and slotted lever quick return motion mechanism or oscillating cylinder engine, right my dear? So we have this 4, very good. Now this is a question we have to match it. Okay, we have to match the following. We have to match the following, and again it is a question of GATE 2006 2 mark, and these are the options. Okay, so what we can do, we can match it. We can match it because the options are on the other slide. Okay, so we can have it matched. Okay, can we do it, please? Can we do it, please? 2016 2 marks. Thank you, Teja. I wish all success to you in the future. And thanks a lot. So we can see the options, my dear. So we can simply match it. No, we can simply match it. Okay, and you can write it on the chat box. Right? Okay. It seems right. Teja, very good. What about the rest of you? What about the rest of you, my dear? So we can simply connect the following. So addendum is something related with gear. We very well know. Okay. The radial distance between the pitch circle, the radial distance between the pitch circles and the addendum circle is what we call as addendum. Instantaneous center of velocity is something related with the linkages, right? Something related with the linkages. So P is matched with 4. Q is matched with 3. Section modulus is something related with the beam, I by Y max. Okay, so this is something from strength of material. And prime circle is something related to the cam. So we have S as 1. We have S as 1. So P4, Q3, R2, S1. So we have B as the correct answer. Right, my dear? We have B as the correct answer. So this is a question of 2 marks asked in 2006. Okay. Okay, so can we try this one, please? Can we now try this one? You guys can give me the answer in the live chat section. Again, a 2006 2 mark question. So you can see a lot of question being asked from the first chapter, that is simple mechanism in theory of machine, right? Please try it. I'm very sure that we can do it. Very, very simple question. Nothing very typical in this one. So simply, I think we reckon that this is a statement of the Grashof law, right? This is the statement of a Grashof law. So in a 4-bar linkage, S denotes the shortest link length, L is the longest link length, P and Q are the length of the other two links. At least one of the three moving links will rotate by 360 degree. Means it may complete rotation. So it is S plus L is equal to P plus Q. Okay, S plus L is less than equal to P plus Q. So we know by Grashof law. What does Grashof's law state? So Grashof's law state that for continuous motion in a 4-bar chain mechanism, the sum of the shortest and the longest link must be less than or equal to the sum of the rest two. So it is basically the statement of Grashof law. So Grashof law statement A is the right answer. Okay, so we have this question now. Can we do it? Can we do it? So two options are on this slide, two options on the other slide. So we can try this one also. Can we try this one, please? So you can read these two options also. So first read the question, you will be able to answer it. I'm very sure about it. Again, a very, very simple question. So lot of questions. This is the question asked. So you may see that a lot of questions are getting asked from theory of machine when IIT Kharagpur is the organizing IIT. So this is the question of 2014, 1 mark. And all these questions are from simple mechanism and velocity acceleration analysis, right? So obviously, like IIT Kharagpur have conducted 6 years, so 40-45 questions are there. So it is not possible to go to do all the questions in one session. Okay, so we'll plan some more sessions if we feel so. Okay, but this is just like you see, we are trying to see for yourself, or you must also try to see that where your practice stands. Okay. So a 4-bar mechanism with all revolute pairs has links LF, LIN, LCO, L output. So F refers to the fixed link, IN refers to the input link, CO refers to the coupler, out refers to the output link. The F in CO out denote the fixed link, input link, the coupler, and the output link respectively. Which of the following statement is true about the input and the output link? Okay. So basically, first of all, we can check by the Grashof law. Again, it is a question of Grashof law. So when we have to see that whether some link can execute of input and output. So when Grashof law, we focus upon the input and output links. Okay, whether they can execute a full rotationary motions or they will oscillate. Okay, so for that we have to first judge whether the Grashof law is satisfied or not. So we see the shortest link is 20 mm. The shortest link is 20 mm and the longest link is 60 mm. So this is my tip, my dear. Remember always to judge or check for the Grashof law first before answering the question. Sometimes what we skip this part and we simply answer by seeing which link is fixed. So don't do that. First check with the Grashof law whether it is satisfied or not. So we can see that S plus L is less than P plus Q. So Grashof law is satisfied. Once the Grashof law is satisfied, my dear, we can say that input and output can execute the full circular motion. Now we see that the link fix is the smallest link. So what we know, when the Grashof law is satisfied, the smallest link is fixed, both input and output rotates completely and make complete motion, that is 360 degrees. So that is the thing, my dear. So both link can execute the complete rotation. Now can we solve this question, please? Can we try to do this question? Can we try to do this question? So these are the options to this question. Okay, so I'll be writing the options here. No need, you can find the answer and can tell me. Okay. So this is a question from velocity analysis, and again 2014 question it is. 2014 set 1 mark question. 2014 set 1 mark question. So today we have targeted to do simple mechanism and velocity acceleration analysis question from the IIT Kharagpur. Okay, asked from the IIT Kharagpur. Obviously, theory of machine is a very big subject, and you see 6 years gate being conducted by IIT Kharagpur. Okay, by IIT Kharagpur. So obviously, it is not possible to do it in one session. Okay, so I hope you guys are practicing questions. Okay, and tomorrow we are having a session on also on that 5 months preparation strategy. And to help you with that, we are coming up with a crash course also. Okay. In that crash course, complete syllabus will be completed. Everything will be completed. Okay. Everything will be completed. Okay. So if any of you have not yet started to the preparation, this is a golden opportunity, because like within the time frame, we are guaranteeing to complete the syllabus in full content, full depth. Like it is not like we are going to skip something, although the pace will be a bit obviously fast, but for the time being, this is a great opportunity. So within 4 to 5 months, the whole syllabus will be completed, okay, in this crash course. So you can check it out. You can visit the website. Okay. Definitely, it is going to help you a lot. So can you try to answer this one? So basically, we have given with the velocities at 2 points of this link, and we have to find the so velocity of a point on this link is very good, Pranjalinda. Very nice. What about the rest of you, my dear? Can we please try to solve it? Can we please try to solve it? Okay, so what we know, so this is just 1 mark question. So what we know that 2014 question. So when we have a point given, like say we have a velocity given of this point. So what we can say, we can draw a 90-degree line from here, and we can draw a 90-degree line from here. And wherever both the lines are cutting, this is the eye center of this link respective to the ground. Okay, respective to the ground. And then we can find the velocity. So basically we have to find Vp. So Vp is Ip into omega. Omega is the angular velocity of this link, and Vq is given. So we understand Vq is Iq into omega. So basically, if we can find Ip and omega, we'll be able to do it. Also, we can do it very nicely. Also, like in short tricks, so 45-90. So this will be 45. See, mostly we get trapped into the play of the geometry. Are you getting my point? So don't do that. Try to manage the question, okay, as sharply. So this is 20, so this will be 70. This will be 70, so this is 90. So 90 and 70, so this must be 20. So this is 45, this is 90, and this should be then 45. So how to avoid the calculation? So Vp by Vq is equal to, we can say, Ip by Iq, right? Ip by Iq. Also, we can see a triangle here. So we can simply do it by the sine rule. So what we can say, IP upon sine 45, I hope we, sine 65, I hope we understand the sine rule. So this is the IP. So we are seeing the angle opposite to this side, that is 65. So putting IP upon 65, and we require IQ. IQ upon sine 70. IQ upon sine 70. So basically IP by IQ is equal to sine 65 upon sine 70. Now let's see the options. So we have this sine 65. So VP by VQ. VP by VQ we just have got. VP by VQ we just have got as sine 65 by sine 70. Now, do we require to, when we see the options, do we require to do any calculation? No, sir, because obviously we understand this, that sine 65 is less than sine 70. Okay, so definitely the answer should be less than 1. And we have only one option which has the value less than 1. So no need any calculation, no need to pick the calculator even, and we can solve this question. So I hope this is also fine to you. If there is a doubt, you please feel free to ask me the doubt in the live chat section. Okay. Okay, my dear. So this is all in this session, my dear. So I tried, we have solved some questions. Mostly all the questions we have solved in this session of simple mechanism and velocity acceleration analysis asked from the IIT Kharagpur. Okay. So lot many questions been asked, from this June. Okay. So any doubt, my dear? Any doubt? Pranjali, Tom quiz, we have done some quizzes previously, and we'll plan soon for some more. Okay. Okay. So we have already done some quizzes previously of theory of machine, if you're referring to that, and we'll soon do. Okay, because so many things are lined up. We are trying to provide as much as possible, right? So fluid mechanics, we have done almost 6-7 quizzes. Theory of machine also we have done 3-4 quizzes. Okay, so we'll plan. We'll try to plan soon as and when possible. Okay. So I hope you guys like this video, and I hope that your preparation is going well. And my dear, this is my advice to all of you. You have to focus on previous year questions very well. Okay. Because they will give you the idea that what kind of questions are getting asked. So 2 things very important: previous year question and test series. Always I give emphasis on these 2. Whether in the live classes also, I suggest these to you guys. Okay. So I hope guys we like this video, and thank you very much for joining in, and do not forget to like and subscribe the channel. We'll see you soon with the next video. Thank you very much.